Air velocity. The atmosphere contains both static and dynamic pressure. Static pressure can be thought of as air at rest. Dynamic pressure is air in motion. P atmosphere, constant, equals static plus dynamic. By measuring the difference between the static and dynamic air pressure and using Bernoulli's formula, we can determine the velocity of the air. What this really is saying is that a fluid or air moving through a tube or over the surface of an object will possess both static and dynamic pressure. The static pressure can be thought of as the pressure exerted on the walls of the tube, and the dynamic as the force of the fluid. The dynamic pressure is the force which you would feel if you placed your hand in the moving fluid. We can also think of dynamic pressure as velocity. As velocity increases, pressure decreases. In this slide, we can see how increasing the dynamic pressure or velocity in the test section will decrease the static pressure we measure at the walls of the test section. The principle of conservation of energy states that energy cannot be created or destroyed, although it can be changed from one form to another. Thus, in any isolated or closed system, the sum of all forms of energy remains constant. By using this conservation of energy statement, we can apply it to the wind tunnel. If we think of air velocity and pressure as forms of energy, this helps in understanding why, as the dynamic pressure or velocity increase in the test section, the static pressure exerted on the walls of the test section will decrease.
Welcome to the MechNet Aero Lab. I'm Professor Kokens, and this is the ping pong ball experiment. What we're going to do is blow a high pressure air out of this tube down between these two ping pong balls. Now, for those of you that know what happens, please don't shout out what happens and ruin it for everybody else. Kind of like when they found out about Santa Claus and your mom said, don't tell your little brother or sister. Well, in my case, it was big sister. But anyways, and just so that we get data, we're scientists, so we have to have data. What we have done is we put a pressure tap on the side of the ball here on this side, and we've connected it to this water manometer so that we can actually measure the pressure on the side of the ball. What do you think is going to happen? Okay, let's turn the air on and find out. Now, as I increase the air pressure, you'll hear the air flowing between the two balls. Now, we're getting a lot more pressure. And the two balls have come together. We'll notice the low pressure area. Now, one common way of explaining this is that with the two balls here and the air blowing between them, we have the air blowing between this area between the two balls, creating the low pressure area and sucking the two balls together. That's only partially correct. What in fact is actually happening is that the air flowing around the outside of this ball is increasing in velocity due to the shape of the ball. So therefore, what happens is we create a low pressure area on this side of the ball. With a high pressure room air pressure on this side of the ball, that pushes the ball in this direction. Now, one thing we have also done, pressure tapped a ping pong ball and placed it in the wind tunnel. Now you can see what we did is we put little brass tubes on the surface of the ball, and so what that's going to do is show the pressure over the outside surface of the ball as the wind is blowing up and over it. And what will happen is you can see this experiment with your recorded data labs. But what happens is the pressure gradually gets lower from each tap until the center will be the lowest pressure. And then after that, all the readings are the same on the backside because the air goes straight away from the ball. Now, as far as the fact that the air is blowing between the two balls and we're restricting the area between there and causing the low pressure, let's try one thing here. Let's try this. Let's take our second ball away and see what happens. I guess that sort of debunks this theory about the air blowing between the two balls. It's just merely the airflow over the ball is causing a low pressure area and causing it to move in that direction.